Okay, we're going to be dealing with Sig Fig rules with calculations. That means when we're adding or subtracting or multiplying or dividing. So first we're going to go ahead and take a look at Sig Fig rules when we multiply and we divide. So you can see there's 8 problems here, and I'm going to go ahead and solve these very quickly just to get our standard answers. So to start with, those are pretty easy, but now we have to apply Sig Fig rules. And when you're dealing with multiplication and division, the rule is the least amount of sig figs wins. So if we take a look at this first one, 8 has 1 sig fig, 4 has 1 sig fig. So really our answer can only have 1 sig fig as well. So that answer of 32, that right now has 2 sig figs. So I can only keep 1. I'm going to keep that. I'm going to look at the 2. The 2 does not round it up, so it just turns into the number of 30. If I look at this one here, 2 sig figs, 1 sig fig. Which one has the least amount? 3 does. It only has 1 sig fig, so I can only keep this value, which means that this is going to round it up, and this turns into 40, which has 1 sig fig. 1 times 3 gives me 3. This has 1 sig fig. That has 2 sig figs. Well, 1 sig fig wins. That's the least amount, so I get the number 3. I don't have to change it all. It's already set. But down here, 3.00, there are 3 sig figs here. There are 2 sig figs here. Well, in this case, this answer only has 1 sig fig. And since it has 1 sig fig, I need to give it the least amount, which is 2 sig figs. So to give this another sig fig, I just go 0.0. Now it has 2 sig figs. If we go over on the side, dividing, same exact rule. 1 sig fig here, 1 sig fig here. That already has 1 sig fig. It's good. This one has 1 sig fig. This one has 1 sig fig. We're all set. It already has 1 sig fig. Now this one has 3 sig figs, and that one has 1 sig fig. 1 sig fig will win. That's the least. So it's still going to be 50. Now in this case, this has 3 sig figs. This one has 5 sig figs. If there are 3 here and there are 5 here, 3 wins. But that only has 1 sig fig. So how do I give it more sig figs? Well, I'd turn that into 50.0. That now has 3 sig figs, just like we should have based on that being the least amount of sig figs. So now let's take a look at Sig Fig rules and addition and subtraction. In this situation, the least precise value wins. Let's put down some math problems and solve what they are without Sig Figs, and then we'll apply the rules to them. Okay, now that I have all the answers in, let's go ahead and apply Sig Figs. In this first one, this measures to the ones place and to the ones place. So my answer can be precise enough to go to the ones place. So I'm going to leave it as 12. That's my answer. This one measures to the ones place, but this one up here only measures to the tens place. So my answer can only measure to the tens place, so I can't have any values in there, like that 1 in the ones place. So it changes to a 20. If we look at this one, this measures to the ones place, and so does this. So my answer can measure to the ones place. If I look at this one can measure as precise as to the 10th, this one to the 100th. This one is least precise, only to the 10th. So I'm going to keep this value and see what happens here. That 5 rounds it up. I get 699.4. If we look at this next one, I'm subtracting these, I get 300.5. Now this one measures 100s, 10s, 1s, and tenths, but this one only measures to the hundreds place, so my answer can only be to the hundreds place. And so I take this number 300.5 and I just change it to 300. And if we think about this with measurements, it kind of makes sense. If I have some device that measures 4 different sig figs, that's pretty precise. That's pretty expensive equipment. If I have another piece of device that I'm using that only measures one thing that's significant up to the hundreds place, I don't want to tell somebody my answer and be very, very, very precise about it and sure about it. I can only be sure to the hundreds value because one of my measurements was done with something using instruments that were least or lesser precision than the top one. Going to this one, 89 minus 7 gives us 82. This measures to the ones place and to the ones place, so I can keep it just like that. Subtracting these two, this one's measuring, neither of them measure to the ones place. This one does measure to the tens, but this one doesn't. This one is only precise enough to the hundreds. So here's an interesting case. If I have 1,400 minus 10, I need to go to the hundreds place. If I go to the hundreds place, well, what happens? My answer is still just 1,400. Even though I did subtract them, when I come to the Sig Fig answer, it's the same answer. And subtracting these two, this one is measuring to the hundreds and thousands. This one's measuring to the hundreds, thousands, and 10,000s. This one is least precise, so I can only go to that level. So it's going to be 0.071 for my final answer.